Technical, okay, fine. Technical issue is good. Is it network problem?
Yes, sir.
Okay. So how is your family? Everyone is fine? Your sister, your mom, your dad, all are fine, mashallah. Hello.
Yes, sir.
Did you did you see the classroom? Google Classroom?
Yes, sir.
What you saw?
Sir, I didn't hear. Can you please repeat?
I'm saying, did you check Google Classroom posting?
What, sir? Google Classroom.
Yes,
Yes, sir.
Google Classroom posting, the
Which
meeting
one?
posting, the meeting posting I gave.
Let me check.
Did you see that one?
Yes, sir.
What is written there?
7:30 to 9.
What is the written? What is written there in topic?
Topic 13.
Yeah, topic 13. Then,
General web properties.
okay, general web
Notes
properties.
on general web properties.
Okay, general web properties. So general web properties means we are done with thermal physics, topic 11 and 12. Now we are going to new section, that is general web properties, and new section is waves. In waves
It
we
is
have in
web.
waves we have four topics. How many topics?
For topic.
Okay, so I'm showing you that. Just give me a minute. I'm also attaching your final term syllabus here, okay? So that you can be clear about this one. How many topics are there in your final term? Do you know?
Which one, sir?
How many topics are in your final term syllabus?
Sir.
How many?
Sir, how many, sir?
You don't know? You forgot?
4. Oh,
So,
sir.
how many?
4.
Four or six?
Can you please share my phone?
Yeah, are you seeing the screen?
Yes, sir. Sir, no share screen. No screen is sharing.
Still no screen?
Yes, sir. No screen.
Okay. That's why you don't understand. Now you'll understand. Now you can see.
Yes, sir.
So can you read the name of the topics?
The topic 11, 12, thermal properties of matter and kinetic model of matter. Topic 13, general wave properties. Topic 14 and 15, light and electromagnetic spectrum. Topic 16, sound.
So we are done with topic 11 and 12, right?
Right. 4 syllabus are left.
Yeah,
Okay.
four topics are left. So these four are all together in section 4 of your Cambridge syllabus, that is waves. Okay, waves, light waves, sound waves, water waves. Okay, all these are combinedly we'll discuss in this topic. Okay, and at the beginning we have general wave properties. That means generally what what are the things common in these waves, and there are how many kinds of waves. Okay, then some of the terms related to waves we are going to learn, like wavelength, frequency, crest, trough, huh? Amplitude. All these things we are going to learn in your previous class, class 7. What you learned from waves? Can you remember? Hmm? In class 7, in which
Okay,
school you were in?
sir. CGS in Chittagong.
Huh? Which school?
Chittagong Grammar School in Chittagong.
Okay, Chittagong Grammar School in Chittagong. So in class 7 you had physics, right?
Yes, sir.
Huh? Yes or no?
Yeah,
So what you learned in that school on waves in class 7? Can you remember?
okay.
What are the things you learned? Chittagong Grammar
Wave,
School is a very good school. It's a
wave,
big school, right?
kinetic energy, types of energy, waves.
Chittagong Grammar School is a big school, right? Look, what are the things there in waves? Do you see?
Yes, sir.
Okay, so can you read from the beginning the learning outcomes?
Content describing wave motion. Oh, learning outcome.
Yes.
Describe what is meant by wave motion as illustrated by vibrations in ropes and springs and by experiments using a Ripple tank. State what is meant by the term wave front. Define the term define the term speed, frequency, wavelength, and amplitude and recoil and use the formula of velocity is equals to frequency into wavelength. Describe transverse and longitudinal waves in such way as to illustrate the differences between them. Describe the use of a ripple tank to show reflection at a plane surface, reflection due to a change of speed at constant frequency. Describe simple experiments to show the reflection of sound wave.
Okay, so here we got at the beginning you see wave motion in ropes, in springs, huh? Then in ripple tank. That means we can have a wave in ropes, we can have wave in springs, also we can have wave in water, right? Ripple tank means it's water tank. And we will also define what is called wave motion. Wave is one kind of energy, right? Wave is one kind of energy.
Yes, sir.
This one you have to know. And how the wave is carrying this energy, uh, that one also will know. Then we have wave front. Uh, Wave front. What is called wave front? We will get the idea. Then we have one formula regarding velocity, frequency, and wavelength of the wave. If you know the frequency and wavelength, then you can find the velocity of the wave. Then we have mainly two types of waves depending on how the energy is transferring and how the particles are vibrating. the wave particles, how they are vibrating. Depending on that, we have two types of waves. One is transverse and one is longitudinal. Okay, and we will have examples out of all these waves. Water wave, the wave in ropes, springs, then sound wave, light wave, which one is transverse wave, which one is longitudinal wave, we will discuss. Okay,
Okay.
then we have the reflection. Wave can be reflected, right? And wave can be also refracted. Refraction. What is called refraction? We'll try to understand. And what will be the behavior of frequency in refraction. Then we have described simple experiment to show the reflection of sound waves. That one also will good. Now the first thing, the definition of wave. Huh? Can you read this part?
Propagation of disturbance that carries energy from place to place in a regular and organized way is called wave.
Wait,
Wave
wait, wait,
transfer.
wait. Propagation of disturbances that carries energy from place to place in a regular and organized way is called wave. So propagation of disturbances, that means it happens like you are hitting one, you know, like your with your finger, with your nail, you are just hitting in your mobile, right? If you touch the other side of the mobile, you will understand that there is vibration, right? Isn't it? Hello. So this one is going by wave. You are like my laptop. Now I am hitting by my nail, and I can understand that I am keeping my hand on the other side of the laptop, and I can feel that some vibration is going on, isn't it? Hello. And if you are like hitting on the wall, one person in other side of the wall, he can understand someone is hitting, right, from the vibration. So this one is also one kind of wave, sound wave. So waves are uh, propagating. That means going forward. The disturbance means the vibration you started in one place. That is one kind of disturbance, right? Hello, are you getting, Farabi?
Yes, sir.
So the vibration you started, that is one kind of disturbance, and that disturbance move forward and carries the energy from place to place in a regular and organized way. This is called wave. Is it clear now?
Yes.
Okay, continue then.
Wave transfers energy and energy spreads as the wave moves.
Yes, continue.
Most familiar are surface waves that travels on water, but sound, light, and the motion of subatomic particles all exhibit wave-like properties.
Okay.
The simplest
So,
waves that
so from our daily experience, like you traveled, you are in Chittagong, right?
sir.
So in Chittagong there is one Potenga sea beach,
Yes, sir.
right?
Yes, sir.
And in the sea beach, if you are going, then you can see the waves.
Yes, sir.
Waves. You can see the waves easily. You went to Cox Bazar also many times, right? Then you also saw their waves, water waves. even in Dhanmondi Lake, in our Buriganga River, everywhere there is some water wave, right? Even you went to village, that time you saw there is wave, right? On water in the pond, isn't it? So water wave we can understand easily, but sound, light, and they are saying also the motion of sub subatomic particles all exhibit wave-like properties. When we will discuss the nuclear physics, that time we will see that alpha particles, beta particles, especially beta particles, they are also showing wave properties. Then X-rays, these are also showing wave properties. So wave are not only water wave, there are many kinds of waves. In the simplest waves, the disturbance oscillates periodically with a fixed frequency and wavelength. So what is frequency and what is wavelength is not clear to you yet,
Yes,
but
sir.
at least now you understand these two things are related to wave, right?
Yes, sir.
When there is some waves, then we have also frequency and wavelength, right?
Yes, sir.
Then continue.
In the most familiar are surface waves that travel on water, but sound, light, and the motion of subatomic particles all exhibit wave-like properties. In the simplest way, the disturbance oscillates periodically with a fixed frequency of wavelength. Mechanical waves such as sound require a medium through which to travel, while electromagnetic waves do not require a medium and can be propagated through a vacuum. Propagation of waves through a medium depends on the medium's properties.
So here we have mechanical waves. Sound wave is called mechanical wave, and light wave, it is called electromagnetic wave. Why? Because sound wave, it requires a medium. Okay, without any medium, it cannot go. Sound wave, right? That's why it is called mechanical waves. And electromagnetic waves, they do not require a medium. You know that from the sun we are getting the light energy, heat energy. In between sun and the earth, there is long distance, no medium available, no air particles, nothing, right? Hello, hello,
Hello, sir. Hello.
yes. So the energy we are getting from the sun, or the wave we are getting from the sun, that is not requiring any medium. That's why it is called electromagnetic wave. Is
Sir.
it clear?
Yes.
And mechanical waves, sound waves, we must need any medium, either air or liquid, or we need solid. Any of the mediums we need for traveling of sound wave. Okay, then propagation of a wave through a medium depends on the medium's properties. That one we'll discuss, where the speed of the wave will be more, speed of the wave will be less. We will discuss that. Okay, clear.
Yes, sir.
Hello.
Yes, sir. Clear.
Yeah. Now another interesting thing.
Sir, all
Uh,
the notes are here.
sorry.
All the notes are here, sir. The things I needed.
Again, please.
Sir, the things I needed already have, sir. Okay, for learning this chapter.
Actually, I am not getting you. There is
Sir,
also
all the
another.
notes are here in this worksheet.
Yeah, yeah. Here I am giving you the notes.
Okay.
Depending depending on the learning outcomes, I prepared the notes on general web properties completely. So you do not need to write so much. When you need anything to write, I will tell you. Everything is written here. You see, everything is there.
Yes, sir.
You see, longitudinal wave, transverse wave, then reflection, then refraction is there, then reflection of sound. And I arranged all the learning outcomes here orderly. The way it's given in the learning outcomes order, the same way I gave the all notes. Is it clear? Is it clear?
Yes, sir.
So look here, the learning outcomes, that serial I maintained here. Ah, you see wavefront. After that, I gave wavefront. Then after wavefront, we gave speed, frequency, wavelength, amplitude, these all things. Then we have speed formula. V equals f lambda. Speed equals frequency into wavelength. Then we have longitudinal and transverse wave. Longitudinal, transverse wave examples. Is it clear?
Yes, sir.
Yeah, this way for all the topics on waves, I will give you notes. Will it be better for you?
Yes, sir.
Okay. Then we are going to discuss now one very important thing about waves. Just be very much attentive during this discussion. I did this experiment in house. You see, in a container, plastic container, that is a bucket, and this one has some water. This on the water, I kept one plastic bottle cap. You know that water, water, 250 milliliter water bottle. That one cap we are keeping here. Then in the middle of the bucket, I I produced wave, and because of this wave, the water, the energy I gave here in the middle, the water is transferring the energy and it's reaching to the corner, right? Till to the last of the bucket. Okay, Farabi. But what one thing I saw that the water is transferring the energy in the next molecules. The water wave is moving up and down because of this energy, but this cap is not This cap is not moving from its place. The cap is staying its own place. The cap is still its own place. So this one is the proof. This one is the proof that water wave, the water particles, they are moving up and down, and by moving up and down, they are transferring the energy to the next molecule, but the water molecules, they are staying in their own place. They are not changing their place. From their place, they are only doing what? They are moving up and down, right? So from this experiment, we understand uh, the water wave transfers energy without transferring particles. It's very important for waves to understand that wave particles, they are only transferring the energy, but they are not changing their place. Is it clear to you?
Yes, sir.
Like there are lots of molecules in water, right?
Yes, sir.
The water molecule in the middle, they are staying in middle. What they are doing? They are only from their place moves up and down and transfer this energy to the next molecules. Then next molecules pass it to next molecule. This way it goes, the energy. But the molecules in the middle, they don't go to the corner. They stay in their place. Is it clear?
Yes, sir.
It's not only for water wave, it's also happening for sound waves. The air particles vibrate and they transfer energy to the next molecule. But air, they stay in their place. Is it clear?
Sir.
During the movement of sound waves. So we are going to have the discussion this one, wave transfer energy without transferring matter. Can you read this, please?
We can understand it from a real life experience. Today you can try using a bucket full of water and a cap of plastic water bottle. You create a gentle wave by dropping a piece of stone from the little height in the middle of bucket full of water. Now keep the cap at any place on the water wave. Observe carefully and you will find that the cap moves up and down only without changing the position of cap with the propagation of wave from center towards the side of the bucket. This proves that water particles transfer wave energy without transferring the cap.
Okay, is it clear,
Yes,
Farabi?
sir.
Very
Yes,
good,
sir.
very good. Then in your copy, in your physics copy, you write this point, the first point. Uh, in your copy, you write the name of the topic, topic 13, general wave properties. We will write very less, but if you write some of the points, it will be very useful for you.
Yes, sir.
Okay, so you write this point. The first point is uh, you write the topic first, topic 13, general wave properties. Then you write wave. Just you write wave as the heading. Then you give one hyphen. Then write okay. By in your copy, you write this line only. Huh? Did you write?
The definition of wave.
Yes, this one. The second line. You
In the
wave
topic name,
transfers, wave transfers energy and energy spreads as the wave moves. Then you write this one. Waves. This line you write. Wave transfer energy without transferring matter. In bracket, after matter in bracket you write molecules.
scroll up.
Molecules.
So can you please scroll up? Scroll up.
Yeah, second one you write this line. Waves transfer energy without transferring matter. This line, the heading, huh? This one you write. And
So can you
in
please scroll
bracket,
up?
yeah, in bracket you write molecules.
Yes, so in wave, I need to write all the points.
No, not all the points. The one I am saying you, that one you write, huh? Not all the points
What can
required.
we repeat?
Which one? This one, waves.
The first one, wave.
The first one.
Yes, sir.
Okay, this one. Wave transfers energy and energy spreads as the wave move.
And then just only this point.
Okay, only write today these 2 points, and in future, in next class we will do more. Okay. Now you do one thing. This note, huh? Uh, you have some minutes. You just go through at home, huh? 20 minutes left, huh?
So can
This
you please
20,
scroll up? I
yeah.
am writing the notes.
This this 20 minutes you just go through, huh? At your home. You have the all the information in Google Classroom, so you can download it from there and you can go through. Okay.
So which point I will write in wave transfer the energy without transferring matter?
Sorry.
In the second one, wave transfer energy without transferring matter. Which point I will write?
Yeah. In bracket you write molecules. After matter, in bracket you write molecules. Matter means molecules. Okay. Here. You do not need to write anything more. Just you write the main points in your copy so that you can recall, right? When you see this line, you can recall this experiment, right? And the notes is also available with you. Is it clear, Parabi?
Yes, sir.
So this 20 minutes, what you will do, you will go through the whole notes, okay, by yourself. And in next class, we will try to continue as much as possible. Then we will also do the worksheet on this topic. Okay.
Okay.
And thank you for joining today's class in school. This way you join in everyday's class. Then you will learn more. Okay. You have
Okay, sir.
more practice. Thank you so much. Huh? Allah Hafiz.
Allah Hafiz.